All right, last topic, structs is just grouped fields. It's a data structure, right? Bringing our data together in some sort of a structure, grouped fields. So here's an example of a struct, person struct. I got two fields, name and age. Name is of type string and age is of type int, right? And then I could create a value person and a value of type person, and that's how I do it right there. Person James 20. That's a struct. We already saw that. And here I'm assigning that to a variable p1, and then print it. And I could also use dot notation to get each of the fields: p1 name, p1 age. And here I'm creating two people: p1 name, p2 name. So you start to see the benefits of a struct, right? I could create multiple values of that type. And here's like you know, p1 doing horizontal, sort of like creating a person and setting it in a horizontal fashion. By horizontal, I mean right here. And I'm specifying each field. But I could also do it like this. I could just specify one field, right? And age right now is 0, the 0 value, right? And viewing the type of P1. So hey, show me the type of P1. It's a person, type person. We've created our own type, a user-defined type, right? Int, bool, string, person. Those are all types in this program. Taking an address of a struct, P1 is of type pointer to a person, right? So here we have a pointer to a person. And we took an address. Here I'm using new, create a new person, right? So it's going to return a pointer to the 0 value. So a new person, P1. And what I do here, first I print P1 and gives me James 20, and it's got the address, so an address where this is stored. And then here I do the type, and it's a pointer to a person, and I do name and age. So it's interesting that even when this is a pointer, I could do .name and, whoops, even when this is a pointer, I could do .name and assign it value, right? It's cool.
Is it going to replace main with whatever function it's inside of? The name?
Oh, main, I don't know why that shows up. I think just because this is like either like package main or your main program. You know, it's the program. I don't know why that's prefixed main. Can we use make with a struct?
No.
Because make's for what?
Make is for channels and maps and what? No.
Slices, channels, maps.
Slices.
I don't know if it's also arrays. No, make is for slices, maps, and channels. For whatever that's worth. And so what's this one doing? P1 and then changing the name and printing the name. So reassigning the name. And what's this one doing? It's doing it without the address. What? Just means, hey, this address, and I'm getting a pointer, so I'm getting the address where that data lives. So let me show you what that looks like. So if I have a variable, I could format println that variable, and I could also format println age : equals.
That's the address of operator?
Yep. And so, right, it gave me the variable value, and then it showed me the address where that variable is stored. So if I was to, you know, age address, right, I could do it like this, is equal to age, and then I could print age address here. I'll see the same thing, or not. Same thing. And then I could do printf, and see the type. And I'll say, hey, it's a pointer. That looks funny. Let me add a new line. it's a pointer to an int, right? So if I wanted to, I could do var age address type pointer to an int is equal to that. That's not idiomatic, but same deal. I'm just kind of clearly showing that's a pointer to an int. That's the type. So the address is address, and then when we get that, we're saying that's a pointer to that address where some value is stored. What kind of value is stored there? Int. Struct types. How do you create them? It's pretty much what we've seen. Empty struct, or a struct with 6 fields. X, Y are both ints, so you could do X, comma, Y, and they're both ints. Use a float32. I'm not going to do anything with that one. It's a throwaway character. I don't know why you'd have that. A is a pointer to a slice of ints. F is a function. Oh. Right? So I could have all those different types in my struct. All kinds of interesting stuff could get stored in there. Put a map in too, I think. And then, it's an exercise. Can you use new to create a variable of a struct type? How many people say yes? It's a gambling question. How many people say no? I think yes. I don't have the answer. That sucks. I'm going to say yes because can you use make to create a variable of a struct type? No. So make is for slices, maps, and channels. New returns a pointer. Newly allocated, 0 valued. So yeah, if we had a struct, we could do a new one. I mean, let's just try it, okay? And that'll be our last little experiment. So how do we create a struct? What's the first thing I type? Type. And then what? The name of my variable of my type. And then what? Struct. And then what? Okay, and then what? So if this is a person, what fields might I want to capture? Naeem. Ayej. Right? And then can we, let's just do a format print line, and we'll do a person. And, okay. 21. Cool. And then we wanted to see if we could do this. P1 is equal to, colon equals, new person. And then format, and then we could do P1 dot Naeem is equal to Kai. And we'll just to heck with the age bit. P1. So new gives us a pointer, right? And we got a little ampersand in front, which means, hey, that's the address where Kai0 is stored. Kai is the name, and 0 is the 0 value for age, because you didn't give me any, because new gives me a new dog, it's a pointer, and it's named 0. So the 0 value of age of an int is 0. Ooh. Whoa. It's cool. All right, so you learned some good stuff today. Make sure you go play with this every day. Like, just spend a half hour and like do your Go coding, because otherwise the midterm and the final are going to kill you.